Okay, so the recording of today's lecture was lost to a fire in cyberspace. The cyberspace security force found a fire, and my data was lost. No, I mean I don't know what happened to the recording. It was corrupted or something. It didn't work. So instead, I'm going back and just re-recording my lecture. But instead of talking directly to people, I am just gonna just talk to no one. Um, Similar to an actual lesson. So let's go through and do this. First off, announcements. The big announcement is the due date for late work. It's December 18th. This is the last day before winter break. If you have any late work, any zeros, get your work in before then. If you don't get your work in before Friday, it's a zero. So just don't. Don't do that. So there's that. Now let's get on to the lesson. Okay. So before we were talking about mass spec. Mass spec is a way that we can figure out the weight and the abundance of different atoms. Okay. So let's go through and think about this. Let's say I'm walking around the school and I find a white substance, and I have 5 grams of this white substance. It could be sugar, baking soda, salt, caffeine, nicotine, cocaine. Doesn't matter. Could be anything. Now, I, as a teacher, have to say to myself, do I need to call the police? This could be cocaine, right? And I'm not going to try it by stuffing it up my nose. It could also be like dried bleach, you know? So I don't know what it is, but I have access to a mass spectrometer. So I don't, but I wish I did. Those things are nice. So I can put in this sample. It's going to break apart everything and tell me the abundance of each element. Okay? So it's going to break everything up and weigh each type of atom. And I go through, and I find out that it has carbon, oxygen, and hydrogen in it. So automatically, anything with nitrogen, I can get rid of. I can say, meh, no more. Don't need to worry about it. And it also tells me the percentages. 40% of it is carbon. For the 53.32% of it is oxygen, and 66.66% of it is hydrogen. So if I want to go through, I can think about it. Okay, I have 5 grams. What's 40% of 5 grams? Well, 2 grams. What's 53? It's 2.66 grams. What's 6% of 5? It's 0.333 grams. All right. So now I have grams, right? So grams are nice, but I can't really compare things, right? Using weights. If I have 5 pounds of watermelons and 5 pounds of oranges, do I have the same number of oranges and watermelons? No. No, I have like 2 watermelons and 20 oranges. So I might have a situation where I have like 30 hydrogens for 2 oxygens, because hydrogens are very, very light. It's kind of like that old riddle, what's heavier, a pound of feathers or a pound of bricks? They weigh the same. It's just that you have 1 brick versus thousands of feathers. So we have that. We need to get the numbers. The reason why we want to get the numbers is because we're trying to get the chemical formula for this guy. Is this C2O3H3? Is this the chemical formula? Because then I can look this up on Google and see what it is. So that's the whole point. All right, so I have this. How do we go from grams to numbers? Well, you guys might remember this because you go from grams to, when we're counting atoms, we count them in moles. So this is going from grams to moles. How do we do that? You divide things by their molar mass. So I'm going to divide each of these by their molar mass. The molar mass of carbon is 12. Molar mass of oxygen is 16. The molar mass of hydrogen is 1. If you don't know where I'm getting these numbers, it's the periodic table. Let me pull that up for you. So again, carbon, it's about 12. Oxygen, about 16. And Hydrogen, it's about 1. Because I'm doing this in my head, I'm just using rounded numbers. If I were you, with a calculator, use the full numbers. Makes life easier. All right. So 2 divided by 12, what is that? Well, 2 divided by 12 is about 1/6. Okay. I'm going to grab my calculator here. 2 divided by 12 is 0.166. So 0.166. Awesome. Now, for this, I'm going to need to do the same thing for oxygen. 2.66 divided by 16. I'm going to let you know. I do it, and it's actually 0.166. Huh. And 0.33 divided by 1 is 0.333. All right. So we have that now. So now we have all of these guys in moles. Hooray. We're going to use molar mass. Okay, there we go. Now we have it in moles. This doesn't really, this gets us closer, but it doesn't get us to that formula because I can't have 0.116 atoms, right? I can't have half an atom. So I need to get these into whole numbers. How do I do that? The way you can do that is by looking for the smallest number of moles and divide everything by that number. And when that happens, you take that smallest thing, let's say carbon, divide everything by 0.166, 0.166, 0.166. If I divide everything by this, that means that this turns into 1. This is also 1. And this is 2. Look at that. These numbers may be a little bit off. Like it may be 2.001 or something like that. And that's fine. Just kind of round to that nearest whole number. So now I know that whatever it is that I'm looking for has a ratio of C1O1 H2. Now you may think, there's the molecular formula. There it is. I can Google this. Not quite. Not quite. So here's the thing. There is an empirical formula and a molecular formula. Empirical formulas are just the proportion of atoms, the ratios of atoms, how many carbons to how many oxygens. The exact number of atoms in a molecule is the molecular formula. So what's the difference? So let's say I had that same thing like this, right? If this is just the ratio, 1 to 1 to 2, this could be the molecular formula, or C2O2 H4. This could be the molecular formula, right? Or what about C3O3 H6? This could be the molecular formula. Or what about C12O12 H24? This could be the molecular form. We don't know because all these have the same ratios, right? It's still 1 to 1 to 2. 1 to 1 to 2. So how do we know which one of these is the correct molecular formula, right? We have the empirical here. How are we going to go through and figure that out? So, again, that mass spectrometer, it doesn't break everything apart. Sometimes it just doesn't break the molecule apart, but we can still see what it weighs. And hey, if it weighs 90, and I know the real molecule weighs 90, what does this guy weigh? 12 plus 16 plus 2. 12 plus 16 plus 2 is 30. 30. So 90 divided by 30, this is times 3, right? So I need to also multiply these guys by 3. So it's C3O3 H6, right? And if I go through and look, C3 O3H6, what we get is glyceraldehyde. Glyceraldehyde, I know, is a main component in vaping. So I've found someone vaping in the bathroom. Yeah, you forgot that there was a story associated with this. So that is how we can go about and figure out the molecular formula from these type of ratios. One last quick thing is that before I gave you like 5 grams of a thing, you don't need the grams even. You just need the percentages. If you get the percentages, you're good. Because if you assume 100 grams, what's 40% of 100? 40 grams. What's 53.2% of 100? 53.2 grams. 6.66% of 100 is 6.66 grams. So if that's the case, what you can do is just remove the percentages and write grams, and you got yourself the conversion done. All right. That's that. I'm going to load this up to Canvas. Hopefully I don't lose any more recordings of lectures, because that's annoying. And I will see you guys on Tuesday for the quiz. Let me talk about that. Since this is coming up as the lecture. The quiz is on Thursday. It's going to be on during our live session. And this is how it's going to go. It's going to be about formal charges, resonance, oxidation numbers, and molecular polarity. So basically everything we learned last week. There we go. All right, guys. Have a good one. See you Thursday.